Good afternoon, sir. My name is Muhammad Sharif. I am CSM B section. Today I am giving a video presentation about the topic Principle and Applications of NMR and IR Spectroscopy. Introduction. Spectroscopy is a scientific method used to study how different substances interact with light. Every material absorbs or gives off light in its own specific way, just like a fingerprint. By observing this light pattern, scientists can understand what a substance is made of and how its molecules are arranged. When a light passes through or reflects from a material, the atoms and molecules inside respond. This response creates spectrum lines or colors that tells us important information about the substance. Using this information, scientists can identify unknown material, check purity, measure concentration, and study chemical reaction without touching or destroying the sample. The principle of NMR spectroscopy. NMR spectroscopy is based on the behavior of certain atoms' nuclei. When they are placed in strong magnetic field, some nuclei like proton and tiny magnetic. How it's work? Spinny nuclei. These nuclei constantly spin on their axis and have a property called a spin. Because of this spin, they behave like a small bar magnetic. When a sample is placed in a strong external magnetic field, this tiny magnetic like nuclei. When the sample is exposed to radio frequency wave, the nuclei absorb energy and jump from the lower energy state to the higher energy state. After absorbing energy, the nuclei return to their original state and release the absorbed energy. This released energy is detected and converted to an NMR spectrum. The key features of NMR spectrum. Sample remains uncharged. Provide a detailed molecule structure. Chemical shift shown the environment of nuclei. Spin coupling gives splitting pattern. Peak area show number of nuclei. Deactive specific nuclei like hydrogen, carbon, fluorine. High revolvation and accuracy. Useful for complexity molecule. Give information about the molecular motion. The principle of IR spectroscopy. It is observation, molecular absorb infrared light casing, vibrational transition in a chemical bond, and absorbed frequency corresponded to bond type and functional groups. Vibration include stretching and bending and unique fabrication. Functional group identification. IR spectroscopy help identify functional group based on the specific frequency. In the alcohol, bond peak around 3200 to 3600 centimeters inverse. In the amine, sharp peak around 3300 to 3500 centimeters inverse. In carbonyl group, strong sharp peak around 1650 to 1750 centimeter inverse. In nitrile, strong peak at 2210 to 2260 centimeters inverse. Complementary nature of NMR and IR spectroscopy. NMR and IR spectroscopy work together in a complementary way to provide a complete understanding of molecular structure. IR spectroscopy help identify the functional groups present in a compound by detecting the characteristic vibration of chemical bonds with oxygen and hydrogen and carbon and oxygen. This makes IR useful for quickly determining what types of bonds or groups exist in the molecule. On the other hand, NMR spectroscopy reveals detailed information about the arrangement of atom by showing how these atoms are connected, what chemical environment they experience. While IR tells us what functional groups are present, NMR tells us how the atoms are arranged around those function groups. When used together, IR provides the molecular fingerprint and NMR provide the structural map, making them powerful tools for completing molecular identification. Application across the field. Spectroscopy include technical like NMR and IR has application across a wide range of scientific and industry field. In chemistry, it is used to identify compounds, determine structure and monitor reaction. In pharmaceuticals, spectroscopy help in drug designing, purity testing and quality control of medicine. In biology and biochemistry, it is used to study protons, enzymes, metabolics, and interaction within cells. It is the science. Spectroscopic method assigned in analysis unknown substance, toxic drugs, and crime scene evidence. Environment science they are used to detect pollutant, monitor air and quality. The study chemical change in ecosystem. In materials science, spectroscopy help characterize polymers, nanomaterials, semiconductors and metals. It is also widely used in petroleum and food industries from testing composition quality and containing a overall spectroscopy plays an essential role in research industry. What to look for spectroscopy. Look at the chemical shift to know the environment of hydrogen or carbon. Check splitting pattern to find the number of neighboring atom. Observe peak intensity area to know how many nuclei are present. Identify number of signs to know how many different environment exist. What look for IR spectroscopy? Look at peak position to identify functional groups. Check strong sharp peak from bond like carbon between and hydrogen. Notice the bond peak from oxygen, hydrogen or nitrogen, carbon. Conclusion. Spectroscopy as a molecular detector. Spectroscopy acts like a molecular detector by releasing information that cannot be seen with the naked eye. By studying how molecules interact with light, spectroscopy helps identify functional groups, determine structure, and understand the behavior of substance. Technical like IR and NMR work together to give both bond information and detailed molecular arrangement. Because of it is accuracy, not distractive nature, and wide use across many fields. Spectroscopy remains one of the most important tools for exploring and understanding the molecular world. This is the all about the spectroscopy for NMR and IR. Thank you for giving this precious opportunity.